In examples 8 and 9, we have some new characteristics that we want to look at identifying. For example 8, we'll still look at identifying domain and range, but we're also going to be looking to identify the intervals on which our function is increasing and decreasing. And then additionally, we're going to be looking to identify both absolute and local extrema. Despite the order this question is written in, we're going to work that process backwards, meaning we're going to start off with the idea of finding local extrema. Local extrema, or I guess I should just say extrema, is just a general word to refer to either minimums or maximums. So when we talk about the idea of finding local extrema, we mean, does our graph have any local minimums or local maximums, which we can identify as either peaks or valleys in our graph. For instance, at x equals -2, we have a peak where our function changes direction, giving us a local maximum, meaning our function value at this point is higher than any of the function values to either side. So we could say that we have a local maximum at x equals -2, and similarly we could identify, in this case, two local minimums, one at -4 because that function value at -4 is lower than any of the function values to either side, and also at +3. So our function values at those two values for x are lower than all of those surrounding function values, giving us a valley. So we have a local minimum at x equals -4 and +3. We can also talk about the idea of absolute extrema, which has some similarities to the ideas of local extrema. We're still looking for a minimum or maximum, but in this case we're looking for a minimum or maximum overall value. So a point where our graph hits its lowest possible function value or highest possible function value. We could start off with the idea of an absolute maximum. But in this case, our graph won't have one, because we can see that our graph continues increasing on both ends. So if our function value continues to increase to infinity, there's no maximum value that we can achieve. We can always find some larger value. But our function will take on an absolute minimum, which in this case is going to be at a point we've already identified. At x equals -3, our function is taking on its lowest possible function value. Our function never dips below this result, meaning we have an absolute minimum at x equals +3. And our y coordinate here is -70. So whether we were talking about that local minimum or this absolute minimum, we could also refer to this by its xy coordinate pair, 3, -70. Again, the distinction here is that this point is an absolute minimum because our function never takes on any lower values than that. At x equals -4, we only have a local minimum because in other portions of the graph we do take on smaller function values. And at x equals -2, we only have a local maximum because this, again, isn't the point where our function takes on its highest function value. Since our graph is increasing on both ends, we're going to continue to achieve larger and larger values. But in this small area, it is the highest point that we hit. Just like at x equals -4, in this local area, this is the smallest function value that we hit. We can use that idea to talk about where our function is increasing and decreasing. To say that our function is increasing, we just need to be able to identify that as we read from left to right, our curve heads up as it does in these two different regions. So we'll identify the interval from -4 to -2 as an interval of increase. And also, using that union notation, identify the interval from +3 up to infinity as another interval of increase. We can identify our intervals of decrease by reading our graph from left to right and looking for any intervals where our function is headed down. So we have two different intervals where that's happening. The first one is from -infinity up to -4. And then we see that same behavior from x equals -2 to x equals +3. So that would be this interval again starting at x equals -2. As we read from left to right, our function is increasing until we hit this point at x equals +3, and then our function changes directions and starts increasing. One thing to notice is that those changes in direction happen at our extrema, whether they're local or absolute. So identifying intervals of increase and decrease and extrema go hand in hand. And then finally we can talk about domain and range. In this case our domain is unlimited or unrestricted, but our range will have a restriction. Since we have this absolute minimum occurring at x equals 3, that's again telling us that our function will never achieve a value below -70, meaning that we have a bottom restriction to our range of -70, but since we have no absolute maximum, our range will continue on to infinity.